Shaken.
Alright, in this video we solve a differential equation using Laplace transforms. This is a revision, and you have to do one of these in the exam. So let's tackle it. So when you have a differential equation, step one would be to convert every element of the differential equation to its Laplace equivalent, right? So from looking at it on a table, we know the Laplace of y will be y bar. The Laplace of dy dt, which is represented by y dot, is s y bar minus y naught, and the Laplace of the second derivative is represented as Laplace of L double dot. Right? So and finally the Laplace of this is given here. So we get these things from the table. Right? We just convert each element into its equivalent Laplace transform, and then we rewrite this equation using these elements, bearing in mind that we found for y dot, which is dy dt, and not 3 dy dt, right? So we found for y and not 2y and stuff, right? So when we put these elements in here, we get the first thing was what? Second derivative, so we get this here minus 3 times this, which was y dot, plus 2 times y bar, right? Is equal to 2 over s minus 3. Good. Now, step 1 is as easy as that. Step 2, insert initial conditions. So we know that at time equals 0, y is equal to 5, therefore y naught is 5. And dy dt being 7 means y subscript 1 is 7. Right? So in this same equation, where we see y0, we will put 5. Where we see y1, we will put 7. And that will produce this. We have 5s there, which people get mixed up often. So you will see me rewriting my s to look different a lot of times in this video. But in the test, I avoided the 5 in your finals. Anyways, so after putting the initial conditions, we get this. Now, what we will do is just simply make y bar the subject of the formula. So, of course, we get rid of all these brackets, but simply by multiplying through, then we group all the y bars term and factorize them out. So we get this. Alright. This was my first attempt. I wrote my S like this, so I can see this is a 5 and this is an S. Good. I transposed everything that didn't have a y bar, and I made it one fraction. We said the instruction is make y bar the subject of the formula. When we get rid of these things here, we want to make everything on the right hand side one fraction. If it's not one fraction, it's going to be very difficult for us to move forward. Right? So after we transpose the 5s minus 8, we find a common denominator. Right? These are not integration signs. This is me trying to make my s look like a 5. But anyways, good. So I found a common denominator, and I made this right hand side one fraction. Then when this was ready, it's one fraction, then I transposed this and I got this. Right? I rewrite this as this, and then I factorize and get this. Good. Of course, you could have factorized first and then throw it over. It really wouldn't matter. Good. Now, when we have made y bar the subject of the formula, next we need to find the inverse, the Laplace inverse of y bar, and then we get the solution for y. As simple as that. So, We have to find the Laplace inverse for this, which is too complicated. It's not on the table. So we will split this into its partial fraction equivalent. Right? I have an unknown over each linear factor. 1, 2, 3. Now we will use the cover up method. So to find A, we would cover up. Oh, all right. To find A, to find what's on top of s minus 3, which is A, we would use this equation and cover up s minus 3 and substitute the value for s. That would make s minus 3 0. To find for B, we will cover up s minus 2 and substitute the value in here in the rest of its fraction that will have made s, the value of s. Sorry, we will substitute. Man, you guys know what I want to say. Alright, and for C, to find C, we will cover up s minus 1 and substitute the value for s that would have made s minus 1 0. And the same thing for B. Sorry for getting a little mixed up there. So let's actually do it. So for A, we still use s minus 3. What would make s minus 3 0? Well, 3. So we cover this up and we substitute 3 everywhere we see s, and what remains. So that's what you're seeing here. You're seeing this, and everywhere you see a s, you see a 3, but the s minus 3 term is gone, and we get 1. For B, we do the same and get 0, and for C, we do the same and get 4. Of course, for B, we would have substituted 2, since we covered s minus 2 and put 2 for s everywhere else, and for C, we would have substituted 1. So, right? Couple this up, put 1 everywhere else, and we get A, B, and C as easy as that. So we will rewrite this as this with A being 1, well, B is 0, so that's gone, and C being 4. So that amounts to this. And when we find the Laplace inverse, we look on the table and simply do the reverse, and we get it like that. Quite simple. All right.
Second.